What if everything you thought you knew about the universe was just the tip of the iceberg? Picture this. Right now, as you're watching this, there are stars exploding, black holes spinning at nearly the speed of light, and entire galaxies drifting farther apart in the vast expanse of space. The universe is not just a backdrop to our lives. It's a living, breathing mystery filled with secrets that defy our understanding. Today, we're diving into 25 surprising truths about the universe that will completely reshape how you see reality. From the mind-bending concept of parallel universes to the eerie hum left over from the Big Bang, these truths will challenge everything you think you know about space, time, and even existence itself. So buckle up, because by the end of this journey, the universe might not just feel bigger, it might feel stranger than you ever imagined. Let's begin. Now turning to our first surprising truth, the universe is expanding faster than we thought. Imagine blowing up a balloon with tiny dots on its surface. As the balloon expands, the dots move farther apart. That's similar to how galaxies in our universe are drifting away from each other. But here's the twist: scientists have discovered that this expansion isn't just happening, it's speeding up. This acceleration is one of the biggest mysteries in modern astronomy. What's causing it? Enter dark energy, a mysterious force that makes up about 68% of the universe. Unlike gravity, which pulls things together, dark energy seems to push everything apart. It's invisible, it's everywhere, and we still don't fully understand what it is. Observations from the Hubble Space Telescope have shown galaxies moving away from us at increasing speeds, confirming this bizarre phenomenon. So, while the universe's expansion might sound like a simple idea, the reality is far more complex and far more fascinating. This discovery doesn't just change how we see the cosmos, it challenges our very understanding of the forces that shape it. Now turning to our second surprising truth, there are more stars in the observable universe than grains of sand on Earth. Let's try to wrap our minds around this. Picture standing on a beach, looking out at the endless stretch of sand beneath your feet. Scientists estimate there are about 7.5 times 10 to the power of 18 grains of sand on all the beaches and deserts on Earth. That's 7.5 followed by 18 zeros, an almost unimaginable number. But here's the kicker: the number of stars in the observable universe is even bigger. Astronomers believe there are around 100 billion galaxies, each containing hundreds of billions of stars. That means the total number of stars could be as high as 1 followed by 24 zeros. To put it simply, if every grain of sand on Earth represented a star, you'd need more than 10,000 Earths worth of sand to match the number of stars out there. This staggering scale doesn't just highlight how vast the universe is, it also reminds us how small we are in the grand scheme of things. It's a humbling thought, isn't it? This truth challenges us to rethink our place in the cosmos and marvel at the sheer enormity of what lies beyond our tiny blue planet. Now turning to our third surprising truth, black holes can spin at nearly the speed of light. These cosmic giants are not just massive, they're also incredibly dynamic. Imagine a black hole as a cosmic whirlpool, spinning so fast that it warps the very fabric of spacetime around it. This phenomenon is known as frame dragging, where the black hole's immense gravitational pull literally drags spacetime along with it as it rotates. To put it simply, if you were somehow able to hover near a spinning black hole, time itself would slow down for you compared to someone far away. This is due to the extreme effects of time dilation, a concept predicted by Einstein's theory of relativity. The faster a black hole spins, the more pronounced these effects become. Some black holes, like the supermassive ones at the centers of galaxies, can spin at speeds approaching the speed of light. This rapid rotation not only distorts spacetime, but also creates intense energy jets that shoot out from the black hole's poles, visible across vast cosmic distances. These jets are so powerful that they can influence entire galaxies, shaping their evolution over billions of years. The idea that something so massive can spin so fast challenges our understanding of physics and reminds us just how strange and awe-inspiring the universe can be. It's a reminder that even the most extreme phenomena out there are governed by the same laws of nature, laws we're still working to fully understand. Now turning to our fourth surprising truth, the universe has a cosmic web structure. Picture the universe not as a random scattering of galaxies, but as an intricate, interconnected network, a vast cosmic web. This web is made up of filaments of dark matter, an invisible substance that makes up about 27% of the universe. These filaments stretch across billions of light years, connecting galaxies and galaxy clusters like threads in a giant tapestry. At the intersections of these filaments, you'll find the densest regions of the universe where galaxies cluster together in massive groups. But how did this web-like structure form? It all goes back to the early universe, just moments after the Big Bang. Tiny fluctuations in the density of matter, caused by quantum fluctuations, began to grow over time. Gravity pulled matter into these denser regions, while the spaces between them became emptier. Over billions of years, this process created the cosmic web we see today. This structure isn't just fascinating, it's crucial to understanding how the universe evolved. The cosmic web acts like a roadmap, guiding the formation and distribution of galaxies. Without it, the universe would look very different. It's also a reminder that dark matter, though invisible, plays a vital role in shaping the cosmos. By studying the cosmic web, scientists can learn more about the nature of dark matter, the history of the universe, and even the fate of everything we see around us. It's a humbling thought that we're all part of this vast, interconnected network, woven together by forces we're still striving to fully comprehend. Now turning to our fifth surprising truth, time travel is technically possible. Yes, you heard that right. Time travel isn't just the stuff of science fiction. According to Einstein's theory of relativity, time isn't as fixed as we think. It's more like a river flowing at different speeds depending on how fast you're moving or how strong gravity is around you. For example, astronauts on the International Space Station age slightly slower than people on Earth because they're moving at incredibly high speeds. This is called time dilation, and it's a real phenomenon. But what about traveling back in time? That's where things get even more mind-bending. One theoretical way to achieve this is through wormholes, tunnels in spacetime that could connect two distant points in the universe. If a wormhole could be stabilized, it might allow for travel not just through space but through time as well. However, there's a catch. Wormholes are incredibly unstable, and we have no idea how to create or control them. Plus, there's the infamous grandfather paradox. If you went back in time and accidentally prevented your grandparents from meeting, would you even exist to make the trip in the first place? Pop culture loves to play with these ideas, from movies like Back to the Future to shows like Doctor Who. While time travel remains a tantalizing possibility, it's also riddled with challenges and paradoxes that keep scientists scratching their heads. Still, the fact that it's even theoretically possible reminds us just how strange and wondrous the universe truly is. Now turning to our sixth surprising truth, the universe is mostly made of dark matter and dark energy. This might sound like something out of a sci-fi movie, but it's a real and mind-blowing fact about the cosmos. Here's the kicker. Everything we can see, touch, and measure, from stars and planets to galaxies and even you and me, makes up only about 5% of the universe. That's right, just 5%. The rest, it's a cosmic mystery. About 27% of the universe is made up of something called dark matter. Unlike ordinary matter, dark matter doesn't emit, absorb, or reflect light, which makes it invisible. We can't see it, but we know it's there because of its gravitational effects. For example, galaxies spin faster than they should if only the visible matter were holding them together. Dark matter acts like an invisible glue, keeping galaxies from flying apart. Then there's dark energy, which makes up a whopping 68% of the universe. Dark energy is even more mysterious. It's a force that's causing the universe to expand faster and faster over time. Think of it as the opposite of gravity. Instead of pulling things together, it's pushing them apart. Scientists are still trying to figure out what dark matter and dark energy actually are. They don't fit into our current understanding of physics, and that's what makes them two of the biggest unsolved puzzles in science. So, while we've made incredible strides in understanding the universe, these invisible forces remind us that there's still so much we don't know. And that's what makes the cosmos so endlessly fascinating. Now turning to our seventh surprising truth, there could be an infinite number of parallel universes. This idea, known as the multiverse theory, suggests that our universe might just be one of countless others, each with its own unique set of physical laws and realities. Imagine a cosmic tapestry where every possible outcome of every decision you've ever made plays out in a different universe. Sounds like science fiction, right? But here's the thing, there's actual scientific reasoning behind this mind-bending concept. One of the key ideas supporting the multiverse theory comes from quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales. In the quantum world, particles can exist in multiple states at once until they're observed, a phenomenon known as superposition. Some scientists suggest that every possible outcome of these quantum events could create a branching of realities, leading to an infinite number of parallel universes. Another piece of the puzzle comes from cosmic inflation, the rapid expansion of the universe just after the Big Bang. Some theories propose that this expansion didn't happen uniformly, and different regions of space could have expanded at different rates, creating separate, bubble universes within a larger multiverse. While we can't yet prove the existence of these parallel universes, the idea challenges our understanding of reality and opens up endless possibilities. What if somewhere out there, another version of you is living a completely different life? The multiverse theory reminds us that the universe or universes might be far stranger and more complex than we ever imagined. Now turning to our eighth surprising truth, the sun is not the center of the universe. This might come as a shock to some, especially since for centuries, humans believed that everything revolved around our star. But the truth is, the sun is just one of hundreds of billions of stars in the Milky Way galaxy, and our galaxy is just one of trillions in the observable universe. So, where exactly are we in this vast cosmic landscape? Our solar system is located in one of the spiral arms of the Milky Way, about 27,000 light-years from the galactic center. That means even within our own galaxy, we're far from being at the center, and when we zoom out further, the universe itself has no true center. The Big Bang, which marked the beginning of our universe, wasn't an explosion from a single point in space. Instead, it was the rapid expansion of space itself, happening everywhere at once. This means every point in the universe can be considered the center from its own perspective. So, while the sun is undeniably the heart of our solar system, it's just a tiny speck in the grand scheme of things. This truth reminds us of our humble place in the cosmos and challenges the idea that we're at the center of it all. The universe is far more vast and interconnected than we often realize, and understanding our true position within it helps us appreciate the incredible scale of existence. Now turning to our ninth surprising truth, neutron stars are so dense, a single teaspoon of their material would weigh 1 billion tons. To put that into perspective, imagine squeezing the entire mass of Mount Everest into a tiny spoon. That's the kind of density we're talking about. Neutron stars are the remnants of massive stars that have exhausted their fuel and exploded in spectacular supernova events. When these stars collapse under their own gravity, their cores are compressed so tightly that protons and electrons merge to form neutrons, creating an incredibly dense object. A neutron star is typically only about 12 miles across, yet it packs more mass than our sun. This extreme density means that the gravitational pull on a neutron star is mind-bending. If you were to drop an object from just 1 meter above its surface, it would hit the ground at a speed of millions of miles per hour. These cosmic objects are not only fascinating but also serve as natural laboratories for studying the laws of physics under conditions we can't replicate on Earth. Their existence challenges our understanding of matter and gravity, reminding us just how strange and awe-inspiring the universe can be. Now turning to our 10th surprising truth, the universe has a background hum. This hum is not something you can hear with your ears, but it's there, echoing through the cosmos. It's called the cosmic microwave background radiation, and it's essentially the afterglow of the Big Bang. Imagine the universe as a giant, ancient firework that exploded nearly 14 billion years ago. Even after all this time, the faint glow of that explosion still lingers, filling every corner of space. This cosmic hum is like a snapshot of the universe when it was just a baby, only about 380,000 years old. At that time, the universe was a hot, dense soup of particles, and light couldn't travel freely. But as the universe expanded and cooled, light finally broke free, and that light is what we detect today as the cosmic microwave background. It's the oldest light in the universe, and it carries with it the fingerprints of the early cosmos. Scientists have studied this background radiation in incredible detail, and it has provided some of the strongest evidence for the Big Bang theory. It tells us that the universe was once much smaller, hotter, and denser than it is today, and it helps us understand how everything we see around us came to be. This hum is a constant reminder that the universe has a story, and we're just beginning to piece it together. Now turning to our 11th surprising truth, there are planets made of diamond. Yes, you heard that right, entire worlds that could be glittering with diamonds. These exotic exoplanets, often referred to as diamond planets, are some of the most fascinating discoveries in the cosmos. They form under extreme conditions, typically in systems where a star has died and left behind a dense remnant, like a white dwarf or neutron star. When a carbon-rich planet orbits close to such a remnant, the intense pressure and heat can compress the carbon into diamonds, creating a world that's essentially a giant gemstone. One of the most famous examples is a planet called 55 Cancri E, located about 40 light-years from Earth. Scientists believe its surface could be covered in graphite and diamond, making it one of the most valuable planets in the universe if only we could reach it. These diamond planets tell us something extraordinary about the diversity of planetary systems. They remind us that the universe is full of surprises, and not all planets are rocky or gaseous like those in our solar system. Some are forged in the most extreme environments, turning into cosmic treasures that challenge our imagination. The existence of such planets also gives us clues about the variety of materials and processes that can shape worlds, expanding our understanding of how planets form and evolve. So, while we may never set foot on a diamond planet, their discovery shines a light on the incredible possibilities that lie beyond our own corner of the universe. Now turning to our 12th surprising truth, the universe might be a hologram. This might sound like something straight out of science fiction, but it's a serious scientific theory known as the holographic principle. According to this idea, everything we see and experience in our three-dimensional world, stars, planets, galaxies, even you and me, could actually be a projection from a two-dimensional surface at the edge of the universe. Think of it like a cosmic version of a hologram on a credit card, where a flat surface creates the illusion of depth. The holographic principle emerged from studies of black holes and quantum mechanics, where scientists discovered that the information about everything that falls into a black hole is somehow encoded on its surface or event horizon. This led to the mind-bending idea that the entire universe might work the same way, with all the information about reality stored on a two-dimensional boundary. While this theory is still being explored, it has profound implications for our understanding of space, time, and reality itself. if the universe is a hologram, it could mean that what we perceive as solid and real is just an illusion, a projection of deeper, more fundamental processes. This theory also challenges our notions of how information is stored and processed in the cosmos, suggesting that the universe might be far more interconnected and complex than we ever imagined. So, while we can't yet prove that the universe is a hologram, the possibility invites us to rethink everything we know about existence and the nature of reality. It's a reminder that the universe is full of mysteries waiting to be unraveled, and sometimes the truth might be stranger than anything we could ever imagine. Now turning to our 13th surprising truth, the moon is drifting away from Earth. You might think of the moon as a constant companion, always there in the night sky, but it's actually slowly moving away from us at a rate of about 3.8 centimeters per year. This might not sound like much, but over millions of years it adds up. The reason for this drift lies in the gravitational dance between Earth and the moon. As the moon orbits Earth, its gravity pulls on our planet, creating tides in the oceans. These tides, in turn, exert a gravitational pull back on the moon, gradually pushing it into a higher orbit. This process is known as tidal acceleration. Over time, this slow drift will have significant effects on Earth. For one, the moon's gravitational pull is what keeps our planet's rotation stable. As the moon moves farther away, Earth's rotation will slow down, making our days longer. In fact, billions of years from now, a day on Earth could last as long as a month does today. The moon's retreat will also weaken its influence on our tides, leading to smaller and less dramatic tidal changes. While these changes won't happen overnight, they remind us that even the most familiar parts of our universe are in constant motion, shaping the future of our planet in ways we're only beginning to understand. So the next time you look up at the moon, remember, it's not just a silent observer, it's a dynamic force slowly reshaping the story of Earth and its place in the cosmos. Now turning to our 14th surprising truth, there are more galaxies in the universe than we can possibly count. Imagine looking up at the night sky and seeing not just stars but entire galaxies, each one a vast collection of stars, planets, and cosmic wonders. Scientists estimate that there are at least 2 trillion galaxies in the observable universe. That's 2 trillion galaxies, each potentially containing hundreds of billions of stars. To put that into perspective, if you tried to count every galaxy at a rate of 1 per second, it would take you over 63,000 years to finish. And that's just the observable universe, the part we can see with our current technology. The real number could be even larger, but how did we come to this staggering conclusion? It's all thanks to advancements in telescopes and observational technology. Instruments like the Hubble Space Telescope and the James Webb Space Telescope have allowed us to peer deeper into the cosmos than ever before, revealing galaxies that were previously hidden from view. These telescopes capture light that has traveled billions of years to reach us, giving us a glimpse into the distant past. What's even more fascinating is that many of these galaxies are incredibly faint and small, making them difficult to detect. But with each new discovery, our understanding of the universe's vastness grows. This revelation challenges our perception of scale and reminds us just how small we are in the grand scheme of things. So the next time you gaze at the night sky, remember, every point of light could be an entire galaxy, teeming with untold mysteries waiting to be explored. Now turning to our 15th surprising truth, the universe has no edge. This might sound like a contradiction. How can something be finite but have no boundaries? To understand this, let's think of the universe like the surface of a balloon. If you were a tiny ant living on that balloon, you could walk in any direction forever without ever reaching an edge. The surface is finite in size, but it's also unbounded. This is similar to how our universe works. It's not infinite, but it doesn't have an edge either. Instead, space curves back on itself, creating a closed, finite system. This idea challenges our everyday understanding of space, where we're used to thinking in terms of straight lines and clear boundaries. But in the cosmos, the rules are different. The concept of a finite but unbounded universe also has profound implications for its shape and size. Some theories suggest the universe could be shaped like a sphere, while others propose more complex geometries. What's clear is that this idea forces us to rethink what we know about the nature of space itself. It's a reminder that the universe is far stranger and more complex than we can imagine. So, the next time you look up at the night sky, remember, you're not just looking out into space, you're part of a vast, interconnected cosmic tapestry with no beginning, no end, and no edges. Now turning to our 16th surprising truth, stars can explode in supernova. To understand this cosmic spectacle, let's take a closer look at the life cycle of a star. Stars, like all things in the universe, have a beginning, a middle, and an end. For most of their lives, stars burn steadily, fusing hydrogen into helium in their cores. But for the most massive stars, the story doesn't end quietly. When these giants exhaust their fuel, their cores collapse under their own gravity, triggering a cataclysmic explosion known as a supernova. In a matter of seconds, a supernova can outshine an entire galaxy, releasing more energy than our sun will produce in its entire lifetime. These explosions are not just awe-inspiring, they're also cosmic factories. The intense heat and pressure forge heavy elements like gold, silver, and uranium, scattering them across the universe. Without supernova, the elements that make up planets and even life itself wouldn't exist. But the drama doesn't stop there. What remains after a supernova can be just as fascinating. Depending on the size of the original star, the explosion might leave behind a neutron star, an incredibly dense object where a teaspoon of material would weigh 1 billion tons, or even a black hole, a region of space where gravity is so strong that not even light can escape. Supernova remind us that the universe is both a place of destruction and creation. They are a testament to the incredible forces at work in the cosmos, and a reminder that even in death, stars give birth to new possibilities. So the next time you gaze at the night sky, remember, those twinkling lights are not just stars, they're the seeds of future worlds born from the ashes of ancient giants. Now turning to our 17th surprising truth, the universe is filled with ghost particles. These elusive particles, known as neutrinos, are among the most mysterious and abundant particles in existence. Neutrinos are so tiny and lightweight that they barely interact with matter at all. In fact, trillions of them are passing through your body every second, completely unnoticed. They are born in some of the most extreme environments in the cosmos, such as the cores of stars, during supernova explosions, and even in the aftermath of collisions between black holes. Despite their ghostly nature, neutrinos play a crucial role in shaping the universe. For instance, during a supernova, neutrinos carry away an enormous amount of energy, helping to drive the explosion and scatter heavy elements into space. But here's where things get even more fascinating. Neutrinos challenge our understanding of physics. They come in 3 types or flavors and can change from one type to another as they travel through space, a phenomenon known as neutrino oscillation. This discovery forced scientists to rethink the standard model of particle physics, which previously assumed neutrinos were massless. Today, neutrinos remain one of the biggest puzzles in science, offering clues about the fundamental nature of the universe. From their role in cosmic events to their ability to defy our expectations, neutrinos remind us that even the smallest particles can hold the keys to the universe's greatest mysteries. So, the next time you hear about a supernova or a black hole collision, remember, there's an invisible world of ghost particles at work, shaping the cosmos in ways we're only beginning to understand. Now turning to our 18th surprising truth, the Big Bang wasn't an explosion. This might sound counterintuitive, especially given the name, but the Big Bang wasn't a massive blast in space. Instead, it was the rapid expansion of space itself. Imagine the universe as a balloon being inflated. Every point on the balloon moves away from every other point, but there's no single center or edge. That's how the Big Bang worked. It wasn't an explosion from one point outward, but rather the stretching of space everywhere at once. This idea is supported by a wealth of evidence, including the cosmic microwave background radiation, which is like the afterglow of the Big Bang. This faint radiation fills the entire universe and provides a snapshot of what the cosmos looked like just moments after its birth. Another key piece of evidence is the observation that galaxies are moving away from each other, showing that the universe is still expanding today. The Big Bang theory also explains why the universe is filled with light elements like hydrogen and helium, which were formed in the first few minutes after the expansion began. But perhaps the most mind-blowing part is that the Big Bang didn't just create space, it created time itself. Before the Big Bang, there was no before. Time, as we know it, began with this event. So, while the Big Bang might not have been an explosion in the traditional sense, it was the moment everything, space, time, and matter, came into existence, setting the stage for the universe we see today. Now turning to our 19th surprising truth, there are planets that rain glass. Yes, you heard that right, glass. One such planet is HD 189,733b, a distant world located about 63 light-years from Earth. This exoplanet is a gas giant, similar in size to Jupiter, but its weather is anything but ordinary. On HD 189,733b, temperatures soar to nearly 2,000 degrees Fahrenheit, and winds whip through the atmosphere at speeds of over 5,000 miles per hour. These extreme conditions create a bizarre phenomenon, molten glass rain, but here's the kicker. It doesn't just fall downward. The winds are so intense that the glass rains sideways, creating a relentless horizontal storm of superheated shards. This kind of extreme weather challenges everything we thought we knew about planetary atmospheres. On Earth, weather is driven by factors like temperature, pressure, and water vapor. But on HD 189,733b, the rules are completely different. The planet's atmosphere is composed mostly of hydrogen and helium, with traces of silicate particles, the same material that makes up glass. When these particles are heated to extreme temperatures, they vaporize and then condense into tiny droplets of molten glass, which are then hurled sideways by the planet's supersonic winds. What's even more fascinating is that HD 189,733b isn't alone. Scientists have discovered other exoplanets with equally bizarre weather patterns, from planets with diamond rain to worlds where it rains iron. These discoveries are forcing us to rethink how planetary atmospheres work and what conditions might exist on distant worlds. They also raise intriguing questions about the potential for life elsewhere in the universe. Could a planet with such extreme weather ever support life, or are these worlds simply too hostile? As we continue to explore the cosmos, planets like HD 189,733b remind us just how strange and diverse the universe can be. They challenge our assumptions and push the boundaries of what we thought was possible, proving once again that the universe is full of surprises. Now turning to our 20th surprising truth, the universe is 13.8 billion years old. This number might seem abstract, but it's one of the most important discoveries in modern cosmology. So, how did scientists figure this out? The answer lies in two key pieces of evidence: the cosmic microwave background radiation and the Hubble constant. The cosmic microwave background radiation, often called the afterglow of the Big Bang, is the oldest light in the universe. It's a faint glow that fills the cosmos, and it provides a snapshot of the universe when it was just 380,000 years old. By studying this radiation, scientists can measure the universe's expansion rate and trace its history back to the very beginning. The Hubble constant, on the other hand, tells us how fast the universe is expanding today. Named after the astronomer Edwin Hubble, This constant helps us calculate the age of the universe by working backward from its current expansion rate. When combined with observations of the cosmic microwave background, it gives us a precise estimate of the universe's age, 13.8 billion years. But why does this number matter? Knowing the age of the universe helps us understand its history and evolution. It tells us how long stars and galaxies have had to form, how elements like carbon and oxygen were created in the hearts of ancient stars, and how life itself had time to emerge on planets like Earth. It also puts our place in the cosmos into perspective. 13.8 billion years is an unimaginably long time, yet it's just a blink in the grand timeline of the universe. This discovery also raises fascinating questions. What happened in the first moments after the Big Bang? What will the universe look like in another 13.8 billion years? And how did everything we see today, galaxies, stars, planets, and even us, come to exist in such a vast and ancient cosmos? As we continue to explore these questions, the age of the universe serves as a reminder of just how much we've learned and how much more there is to discover. It's a testament to the power of science and human curiosity, and it challenges us to keep pushing the boundaries of what we know. Now turning to our 21st surprising truth, there are black holes that sing. Yes, you heard that right, black holes, those mysterious cosmic vacuums, can produce sound. But how does something so massive and seemingly silent create sound waves? The answer lies in the gas clouds surrounding supermassive black holes. When a supermassive black hole pulls in gas, it doesn't just swallow it quietly. Instead, the gas spirals around the black hole, forming a swirling disk. As this gas moves, it creates pressure ripples like waves in a pond that travel through the surrounding gas clouds. These ripples are essentially sound waves, but they're not the kind of sound we can hear with our ears. They're incredibly low-frequency vibrations, far below the range of human hearing. Astronomers have detected these eerie sounds using powerful telescopes and instruments. One of the most famous examples comes from the Perseus galaxy cluster, where a supermassive black hole has been singing for billions of years. The sound waves it produces are so deep that if we could hear them, they would sound like a B-flat note, but 57 octaves lower than middle C. That's a note so low it would take millions of years to complete a single cycle. But why does this matter? These sound waves aren't just a cosmic curiosity. They play a crucial role in shaping the universe. The pressure ripples created by black holes can heat up the surrounding gas, preventing it from cooling and collapsing to form new stars. In a way, black holes act like cosmic regulators, controlling the growth of galaxies by limiting star formation. This discovery also challenges our understanding of black holes. We often think of them as silent, destructive forces, but they're far more dynamic than that. They're not just consuming matter, they're actively shaping their environments, creating waves that ripple across the cosmos. So, the next time you look up at the night sky, remember, somewhere out there, a black hole is singing, its deep, resonant tones echoing through the universe. It's a reminder that even in the darkest corners of space, there's a symphony of activity waiting to be discovered. Now turning to our 22nd surprising truth, the universe could end in a big rip. Imagine a scenario where the very fabric of space and time is torn apart, leaving nothing but chaos in its wake. This might sound like science fiction, but it's a real possibility based on our current understanding of dark energy. Dark energy, the mysterious force driving the accelerated expansion of the universe, could one day become so powerful that it overcomes all other forces in the cosmos. If this happens, it wouldn't just push galaxies apart, it would rip apart everything from stars and planets down to atoms and even the building blocks of matter itself. This catastrophic event is what scientists call the Big Rip. The idea of the Big Rip comes from observations of how dark energy behaves. Right now, dark energy is causing the universe to expand faster and faster. But if its strength increases over time, it could reach a point where it becomes unstoppable. Galaxies would be pulled apart first, followed by solar systems, and eventually, even the bonds holding atoms together would be torn asunder. The universe would end not with a bang, but with a violent, all-consuming tear. What's even more fascinating is that this theory isn't just speculation. It's grounded in mathematical models and observations of the universe's expansion. While we don't yet know for sure if the Big Rip will happen, it's a stark reminder of how little we truly understand about dark energy and the ultimate fate of the cosmos. If the Big Rip were to occur, it would mean the end of everything as we know it, but it also raises profound questions about the nature of the universe. Could there be something beyond the Big Rip, or would it truly be the final chapter in the story of existence? These are questions that scientists are still grappling with, and they remind us that the universe is full of mysteries waiting to be unraveled. So, as we ponder the fate of the cosmos, let's take a moment to appreciate the delicate balance that holds everything together for now. The Big Rip may be a distant possibility, but it's a powerful reminder of just how dynamic and unpredictable the universe can be. Now turning to our 23rd surprising truth, there are stars older than the universe itself. Yes, you heard that right. One star in particular has baffled scientists for years. It's called the Methuselah star, named after the biblical figure known for his incredibly long life. This star, located in our own Milky Way galaxy, is estimated to be around 14.5 billion years old. But here's the catch: the universe itself is only about 13.8 billion years old. How can a star be older than the universe it exists in? It's a paradox that challenges everything we think we know about cosmic history. The Methuselah star's age was determined using precise measurements of its brightness, temperature, and composition. By studying these factors, scientists can calculate how long the star has been burning. But when the numbers came back, they didn't make sense. How could a star exist before the universe itself? This contradiction has led to intense debate among astronomers and cosmologists. Some suggest that our measurements of the star's age might be off, while others propose that our understanding of the universe's age needs re-evaluation. One possible explanation lies in the way we measure the universe's age. The 13.8 billion year estimate comes from observations of the cosmic microwave background radiation, the afterglow of the Big Bang. But what if there's more to the story? Could the universe be older than we think? Or could the Methuselah star have formed under unique conditions that make it appear older than it really is? These are questions that scientists are still working to answer. The Methuselah star isn't just a cosmic oddity, it's a reminder that the universe is full of surprises. It challenges our assumptions and pushes us to rethink what we know about time, space, and the origins of everything. As we continue to study this ancient star, we may uncover new clues about the early universe and the processes that shaped it. For now, the Methuselah star remains one of the most fascinating mysteries in the cosmos, a celestial puzzle that keeps scientists and all of us looking up at the stars in wonder. Now turning to our 24th surprising truth, the universe is filled with cosmic strings. These are not the kind of strings you'd find on a guitar or a piece of fabric. They're one-dimensional defects in the fabric of spacetime itself. Imagine the universe as a vast, intricate tapestry. Cosmic strings are like tiny, invisible threads woven into this tapestry, remnants of the early moments after the Big Bang. They are thought to be incredibly thin but unimaginably dense, stretching across the cosmos for billions of light years. Cosmic strings are a fascinating prediction of theoretical physics, arising from the idea that the early universe underwent a series of phase transitions, much like water turning into ice. During these transitions, imperfections could have formed, creating these one-dimensional structures. While they haven't been directly observed yet, their existence could explain some of the most puzzling phenomena in the universe. For instance, cosmic strings might have played a role in the formation of galaxies and large-scale structures, acting as gravitational seeds that pulled matter together. Detecting cosmic strings is no easy task, but scientists have a few ideas. One method involves looking for their gravitational effects. Because cosmic strings are so dense, they would warp spacetime around them, creating ripples that could be detected as gravitational waves. Another approach is to search for their impact on light. If a cosmic string passed between us and a distant galaxy, it could bend the light in a way that creates double images of the galaxy, a phenomenon known as gravitational lensing. The study of cosmic strings is still in its early stages, but the implications are profound. If they exist, they could provide a window into the universe's earliest moments, helping us understand how everything began. They might also hold clues about the nature of spacetime itself, challenging our understanding of gravity and the fundamental forces that govern the cosmos. As we continue to explore the universe, cosmic strings remind us that even the most exotic ideas in science can lead to groundbreaking discoveries. They are yet another example of how the universe is far stranger and more mysterious than we ever imagined. Now turning to our final and perhaps most poetic truth, we are made of stardust. Every atom in your body, from the calcium in your bones to the iron in your blood, was forged in the fiery hearts of stars. When the universe was young, only the simplest elements, hydrogen and helium, existed. But as stars formed, lived, and died, they became cosmic factories, creating heavier elements through nuclear fusion. When massive stars reached the end of their lives and exploded in supernova, they scattered these elements across the cosmos, seeding the universe with the building blocks of planets, oceans, and life itself. Think about it: the carbon in your DNA, the oxygen you breathe, and the nitrogen in your cells were all created in the cores of stars that burned billions of years ago. In a very real sense, you are a living, breathing piece of the universe, carrying within you the remnants of ancient stellar explosions. This connection between humanity and the cosmos is not just scientific, it's deeply poetic. It reminds us that we are not separate from the universe but an integral part of its grand story. This truth also highlights the incredible journey of matter across time and space. The atoms that make up your body have traveled across billions of light years, survived cataclysmic events, and come together in just the right way to create you. It's a humbling thought, one that underscores the beauty and interconnectedness of all things. As we look up at the night sky, we're not just observers of the universe, we are the universe looking back at itself. And so, as we conclude our journey through these 25 surprising truths, we're left with a profound sense of wonder. The universe is vast, mysterious, and endlessly fascinating, filled with phenomena that challenge our understanding and ignite our curiosity. From the expansion of the cosmos to the echoes of the Big Bang, from the dance of black holes to the whispers of cosmic strings, each truth reveals a piece of the cosmic puzzle. But perhaps the most remarkable truth of all is this: we are not just explorers of the universe, we are its children, born from the stars and forever connected to the cosmos. Thank you for joining us on this journey, and don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. The universe is full of mysteries waiting to be discovered, and we can't wait to explore them with you. Now turning to our final thoughts, let's take a moment to reflect on the 25 surprising truths we've uncovered about the universe. From the mind-bending reality that the universe is expanding faster than we thought, to the awe-inspiring fact that we are made of stardust, each truth has challenged our understanding of space, time, and existence itself. These revelations remind us that the cosmos is far stranger and more wondrous than we could have ever imagined. We've explored how black holes spin at nearly the speed of light, how the universe hums with the echoes of the Big Bang, and how planets can rain molten glass. We've grappled with the mysteries of dark matter and dark energy, pondered the possibility of parallel universes, and marveled at the sheer scale of galaxies and stars. Each truth has peeled back another layer of the cosmic onion, revealing just how much we still have to learn. But perhaps the most profound takeaway is this: the universe is not just a place we observe, it's a story we are part of. Every discovery, every mystery, and every truth connects us more deeply to the cosmos. Whether it's the realization that time travel might be possible or the humbling thought that we are made of atoms forged in ancient stars, these truths remind us that the universe is not just out there, it's within us. As we close this journey, let's remember that the universe is still full of mysteries waiting to be uncovered. What lies beyond the cosmic web? Could we one day unravel the secrets of dark energy? Are there other versions of reality out there waiting to be discovered? The answers to these questions are out there, and they're waiting for curious minds like yours to find them. Thank you for joining us on this cosmic adventure. If you enjoyed exploring these surprising truths, don't forget to like, share, and subscribe for more mind-blowing content about the universe. Hit the notification bell so you never miss an update, and let us know in the comments which truth amazed you the most. The universe is vast, mysterious, and endlessly fascinating, and we can't wait to keep exploring it with you. Until next time, keep looking up and wondering. The cosmos is calling.